and welcome to my talk about Tales from the Dev side, where I will tell probably some funny stories that we as a business experienced. Hopefully it's somewhat entertaining. I'm really glad so many people are interested in that. So thank you already for that. First of all, about me, I'm Johannes. I have some work experience as well in the nuclear power plant, where I was surprised of the technology they are using. It's pretty old, but pretty solid as well. I worked at the radar station at the Bundeswehr, the German military. And I also worked at the Institute for Information Systems, which has the really unfortunate abbreviation ISIS. And currently I work at XDev Software, which you probably know by now. And I do a lot of helping out for customers in various projects. And I also am a big open source contributor. All right, so you can read that, and if you're done with that, we'll continue. Okay. Some people got the joke. So of course we won't do that. We'll start with the buzz factor. Also a funny thing, but it's really helpful. So the buzz factor was first found in an email from 1994, and my boss Richard, he keeps using it and references it. So it's really funny. It defines how many people of a team can be run over by a bus until the project comes to a complete halt. So basically until you can't do any work in the project because nobody knows what to do really. And so the goal of the buzz factor is to have a high buzz factor. You want to be able to well, that sounds bad, but you want to be able to lose a lot of people in a project without coming to a halt, right? And a low buzz factor is not good, so the lowest buzz factor would be 1, so you have one person who really knows how the project works, and if the person is gone, it doesn't have to be a bus, it can also be a car. No, it can also be that he or she quits or gets fired, something like that. So back in the day, software development was like Rambo, right? The developers felt like Rambo because they had to do everything on their own. They fought the good fight, they programmed day and night, and they have to suffer as well, right? For the company, for the code, for the project. But around 2010, there was a big change. Some companies changed sooner, some later. But there was a change from being a solo dev to working as a team and making a team effort. And that's where we come actually in. So let's go to our first project. There's this dude, he's called Robert. And Robert felt like Rambo as well. So he was a solo developer. He was actually really good at what he did, and he also enjoyed it. But his boss, he wanted to increase the buzz factor. So he wanted to have more people that are basically expendable, right? And that was not really good for Robert. So the bunch of new developers came into the project, and Robert was not happy about that because he had to explain constantly what to do, how to do it, why to do it, and stuff like that. And Robert was a really good developer, but he wasn't a great communicator. So he was in a bad mood, and the new developers were in a bad mood as well. And we were tasked to help distributing the workload for this team. And what we did was we standardized the workflow. That was our first thing we did. And how did we do that? In 4 basic steps, we set up a Git host, right? A Git, I think you should know that by now. is really important. You can use GitHub, GitLab, Git, whatever you want, but use Git. And this is essential for collaboration because it tracks changes in the code, it enables seamless coordination of workloads, and it also handles conflict resolutions by having commits and merges and stuff like that. So the next thing we did was use the Git feature branch workflow, which I'll get into later. But basically, you create a branch for an issue, you work on that branch, you create a pull request, and then this pull request is peer-reviewed. Basic. All right, and then we also needed an issue tracker for that. Oh, yeah, sorry, that's just, you can use that with any Git, of course. We also needed an issue tracker. You can use Jira for that, and then again, GitHub, Git or GitLab also have an issue tracker, which is pretty useful, or you can also use Trello if you want to go a bit more lightweight. But the point is, you have to create issues and describe the actual goal of this issue, what you want to solve. And then usually you should also document or write the process of your fixing that issue and also the result if you're really into it. And that helps you currently by just having documentation, and also future you, because you can remember what you did, and also, of course, other developers who are also working on that project and want to know what's going on. And also the management wants to know what's going on, and they know that by seeing over the issue tracker, which is great. And lastly, we also needed a wiki, which is really useful. So we can use Confluence or GitHub, GitLab, Gitty again. They all have included wikis, which are really great. And it helps a lot with onboarding, or you can also document tricky parts of your project. Okay, so I'll tell you the Git flow workflow. First of all, we create an issue. And we try to describe the task at hand in as much detail as possible. That's really important, that you give it all the details you need. Then the next step is to create a separate branch that enables you to have an undisturbed area where you can commit without any interference, without any developer interfering with different commits as well. And it lets you rapidly push those commits without having merge conflicts, of course. The next step is you do the actual work. That's where you really get into it. That's the fun part of programming, right? You do the work and you also document that. That's important step. So that's in parallel, basically. You want to do the work and do some documentation in the issue where you have problems, why it took so long, maybe something like that. And you also fill the wiki as well. So if you're done with the work, you create a pull request for that. But you don't merge it yet. You let some colleague peer review that pull request. And that's really important as well. So our standard procedure is some colleague who knows a bit what he or she is doing is actually commenting the code. So the person is testing the issue if it's solved by your code, and it's also the code is also reviewed, and you can leave some comments on the issue, what's the problem in the issue, or what's the problem in the code. And what we usually recommend is that you don't then fix that, but you first of all talk to each other. So the person who implemented the code and the person who reviewed it, they talk to each other about how to solve it, how to fix it. Then the person who implemented the issue actually fixes it, and then another peer review, and then hopefully everything is fine. And then you can do the simple merge with one click, hopefully, if you don't have any conflicts. And lastly, you can close the issue. Whew, that's a long way, but it really has a lot of benefits. So first of all, there's a knowledge transfer between the person who implemented it and the person who did the pull request, the peer review. So they usually have to talk to each other, and there is some knowledge transfer because there's always a reason why there are problems and why something is not fixed or something like that. And it also raises the quality of the code, of course, because if two people look at the same code, they will see different bugs, different errors, or can fix it differently. And then you get independence. So every developer is independent from each other, at least in theory. Of course, you have to talk to each other again, because somebody might know some parts of the code better than the other, stuff like that, but you are basically independent. And you have documentation. That's amazing. So by just writing down what you did and how you did it and what was the result, you get documentation through the issues and also hopefully through the wiki. So that's how it started, and when we were done with them, they were all happy. And notice the life expectancy. Robert now lives not just 56 years, but 84. That's amazing, right? So we basically expanded his life a little bit, and that might sound funny, but it's really a mental health thing, and mental health is something that's serious, and people are living longer with better mental health. All right, so the next project which we had was a fight of the mind. So we have Juanita, and she was in a, well, I have to drink something, sorry. Whew. All right. My voice is leaving me. So Juanita was in a project with a low buzz factor. And she had one specific problem. Her pull requests got constantly rejected because of formatting. So the problem was like this. She had a very important co-worker who said, well, this line of code is all right, but you need to format it differently. You have to have each call of the Stream API in a different line, which isn't that uncommon. It's pretty easy and pretty good, I think. It's a good strategy for formatting. But then again, another commit was like that. So she did what the very important coworker said, but he was not satisfied with that because he wanted to have that all in one line. And why? Yep, because it's really short. So it's much, much more efficient to write it in one line. Okay, so that's very subjective and left Juanita very irritated. And we don't want that. But there are many areas in the code where stuff like this happens. So there is a big war happening all the time somewhere in your company where people discuss tabs versus spaces, if you use tabs or spaces in your code or for indentation. Another thing is the curly brackets. Should they go into the new line or should they be in the same line as the if statements? Or final variables. Are you using final variables? Where are you using them? Or is it mandatory? Stuff like that. And of course, the classic, how many lines, how many characters per line? So what was the solution? A code formatter. That's a little algorithm that runs through your code and it applies some simple or complex rules to format your code in a deterministic way. And that means if you have some piece of code, it always leaves the code formatter in the same way. It's deterministic, always the same. And these code formatters are included in all major IDEs. I just show the IntelliJ one here, where you can also import a scheme, the IntelliJ scheme or Eclipse profile. That's really good because you can actually use some Eclipse code formatting, but you can also create your own by clicking through all these options and all these tabs, which is a lot, but still, you can change it anytime, and that's a cool thing. But the difficult part is not implementing that code formatter, it's actually to find the common code style in your team. So people are really passionate about that, but you should try to not invest too much time on that, because any style is fine as long as everybody uses the same code style. All right, and that means it's readable through the whole project, and it basically makes the code more readable, and you can keep your focus much better. By not focusing on the code style, you just write your business logic and you're done with that. What you can also do, and what we continuously do, is activate some save actions in IntelliJ, so every time you save your code, it actually gets automatically formatted. There's also a hardcore option I heard about where people actually configure their CI pipeline. So every commit they do, it gets automatically formatted by the CI pipeline. But I wouldn't recommend that. That's crazy. But I thought it was funny. So by using that, by using the code formatter, Juanita really was happy again, and she also got a little boost in the life expectancy. All right, so the next project. That's actually what the Microsoft designer drew when I asked for the perfect programmer. Let's call him Bob. And Bob is very dear to me because he keeps up to date, all right? So he's reading blogs and news, he listens to podcasts and session, he constantly tries out new stuff, which is great, right? But still, Bob was unhappy in this project because he was constantly behind with the versions of his libraries. And almost every day there is a new version of some library released that he uses, and he was simply too busy to keep up with all these versions. So he felt like it was his duty to update all the dependencies, and what we used are dependency update tools for you. I thought it was funny. Okay, because there is no name for these kind of software. It's a dependency update tool, and there is Dependabot around and Renovate. Dependabot is proprietary software from GitHub. It's really easy to set up with one click. We'll do that in a second. And there's also Renovate, which is open source, and you can actually self-host it. And it's also runnable on GitHub Actions or on Jenkins and GitLab Runner. But what they do is, first of all, they search for dependency in your project. Second of all, they search for the newest versions of these dependencies. They update these dependencies in your project, and then they create a pull request for this new version. And we can see that right now. Okay, so bear with me. I'm trying to get that running. Well, yes, that's great, but I need actually duplicate my screen so I can work. Hello. All right, you've seen what I see. That's great. So I created a little Dependabot demo. It must be a public repository, otherwise you have to pay for that, and we don't want that. We go to the settings of this one. Oh, it's a basic Spring repository where I used an old Spring version. So we're going to the settings, the advanced security, and you see there are a lot of options for Dependabot. What we want is the Dependabot version updates. And we enable that with one click, but we also have to put in the package ecosystem, where we use Maven, of course. So we commit these changes. Yes. And just like that, it's activated. And if we look to the actions, you might see there is this action, the dependabot update running now. All right. But it takes a while, so we're going back into the presentation for a few seconds at least. Oh, this is good, but this is better. All right, this was the quick demo. We'll come back to that. So what do you get? You constantly get an update. You update all the versions of the dependencies you are using, and that's amazing. It's basically a one-click merge. I just have to type that in one time, and next time I just merge all these pull requests. And what's also really useful in this case are tests. So if you have automatic tests in your project, then these pull requests that are created already run through all your tests that you have, and you can see if there are any errors by updating your library. And I think now it's time to go back. Whoop. Was that the wrong one? Yes, that was the wrong one. So we duplicate. Okay, now I deactivated the touchpad. All right, here we go. Okay, so these actions are done. And we can actually see, hopefully, that there was this pull request created. So this was created by the dependabot. If we look into it, all it does really is one change of one version. So it simply updates this version. And what we can do now is just merge this one. You see there are no conflicts. And if we would have some tests, they should be green. And if they are not, you know, you shouldn't merge, right? But we can merge, confirm the merge, and just like that, we are done with the version update, which is great. All right, trying to get back. Good again. Better. Cool. So this is simply how the dependabot works. It's really easy to activate and even easier to use. So this made Bob quite happy because he could automate all these libraries and still keep up to date. All right, next project. So we have that random developer called Johannes. Johannes is a senior software engineer at some random software company, and he constantly has to change projects. He has to familiarize himself with a lot of code in little time because he switches so much. And Jerry Reed actually made a song about that. We've got a long way to go and a short time to get there. Because what happens if he does a small change in some area of the project he doesn't fully understand? In some area, some completely different area, something might break. And then Johannes looks like an idiot, and that's bad. That's bad for him at least. So what can we do? We try to describe the behavior of the application. And how do we do that? With tests. Tests are great for that because they explicitly describe your application. So we really want to test everything here. If you have some weird behavior, if you find some weird behavior in this application, like this one, the null card should not be greater than a real card. Why? I don't know. That's not the point. The point is you want that this behavior tested because that's how the application behaves right now. So if you have that test and you might change that behavior later, this test breaks and you get notified. And then you can really think about, should that be the case or not? But right now, that's the case, so you want to create a test for that. If you know what behavior you want, create some test. So this is pretty easy. You have a 10 of hearts and a 9 of hearts, and the 10 of hearts should be higher than the 9 of hearts. So that's pretty easy, and I think that's the most common tests, like really easy behavior, really easy to understand. And if you don't know if something behaves correctly, write a test. So how should the card comparator behave here? You compare a 10 of hearts and a 10 of, I think, the spade. And I have no idea how that should be compared, but the program knows how it's behaving right now, so you write a test. And you can also write a to-do. If this test ever fails, the developer will be notified, will go to that test and see what that does, and then he might even read some Java doc. So what we have by that is documentation as code, documentation in code even, and that's amazing. And if some behavior changes, the tests fail. And that's what we want, because we get notified about this change we might not even want, right? So write tests as much as you can, but at least write one test or something for each issue. That's a pretty basic understanding and something that really helps. So by writing more tests, Johannes actually can now enjoy driving his Trans Am through America. And there's also a talk on Thursday at 12:30 from Francois Martin. He talks about the test toolbox. So if you're interested in that, you can go to that talk. All right, next project. So we had a project with an existing Java desktop client. We supported the existing team with some stuff, and they had a very important coworker once again called Salvatore. He was quite sure of himself, which isn't a bad thing in general. But in this project, we had some new requirement that there should be a notification in Windows that should pop up if some article was added or something like that. And everybody in this project was working in Java because we had that Java desktop client. But Salvatore, he wanted to write that in C#. Well, he thought it's not possible in Java. I don't know why he thought that, but he did. And so he wrote a C# background service with hundreds of lines of code. And it ran in the background and was executed by the database actually in a really tricky way, and he really put his mind to it. So he didn't ask anybody about that until it was finished. And he didn't use any standard tools because he was just simply perfect, right? So his guiding principle was, if you want something done right, do it yourself. The problem was, on each notification, a new service spawned. So as you got more and more notifications, more and more services ran in the background and basically just crashed the machines. We fixed that pretty quickly, but again, new problems arose, and nobody else could fix them because it was C# and everybody on the team was working on Java, right? So it was a really difficult thing. Also, Salvatore, it was his first C# program. Amazing. But what we did was we fixed that in like 10 lines of Java, because it's a really easy thing to do and it's nothing new or anything. It's just basic Java stuff where we create a tray icon, we set an image, we put that tray icon into the system tray, and then we display a message. Okay, so that's really easy, and Salvatore actually was quite humbled by that, but notice his life expectancy did not change, okay? So he was still fine, but we had very different principles. So you can follow your ideas, that's an amazing thing to do, and that's what we want to do as developer. We want to realize ourselves, and you can do that, but you should stay practical and efficient if possible. you should really value your colleagues' opinions and ask them for help or advice if possible. Because usually they really want to help. Sometimes not, but even then, asking is not a bad thing. Use standard tools if possible. Why not? Because nobody is perfect, but you can at least try to use something that's standardized, that a lot of people use. Yeah. And if you want to do something right, find existing solutions, because that's a really good default. All right, so these standard tools usually have less bugs. That's what you actually want most of the times in applications. You don't want to have many bugs. And just because these tools are so broadly used, it would be good to use them. And a lot of bugs are already fixed. You also have less duplicates, because all the code you wanted to implement yourself a lot of times is already implemented in these standard tools, right? And by less duplicates, it becomes less complicated, less complex, and by that, it becomes more readable. And that's also one thing that you really want in your application. And they even might address problems that you are not even aware of in many cases. Okay. So eventually, Salvatore, in this case, was a really good part of the team, and we worked well with him, eventually. But of course, there's always the part, well, there is no solution. What can we do? What we do a lot of times is we open source our own solutions. So we implement those solutions ourselves, but then we open source them, as we did with the Vardin Maps leaflet flow, which basically just displays an OpenStreetMap in Vardin. We created the Vardin editable label, which lets you somehow lock a label. We implemented the XDev Spring Data Eclipse store, which I actually held a talk about last year, if some of you might remember. And we also implemented the CST dip Java client, which is a client for the Bundeszentralamt für Steuern, as everybody knows. It's the Federal Central Tax Office, and you really have to talk to them in a very weird way, and we just made it easier with our client. And what you get by open sourcing your own solution or part of your own solution is you give back to the community. That's amazing. And you also show expertise to maybe potential clients, right? If they see the code or if they see the application you have and they like that, then you are already in a good area. And you might get feedback, or even better, bugs from users. And then you can fix them. And maybe you didn't even encounter those bugs yet. So you can fix them before you encounter them. Pretty cool. And if you're really, really lucky, you might even get fixes from user, but I think that happened one time with us, so that's a long shot. There's also another Johannes Bechberger. He will be tomorrow at 9. He will have a session about writing an open source library. So if you're interested in that, you should be there tomorrow at 9 for Johannes Bechberger. All right, how are we on the time? Oh, good. Good. I was in the same project, in the same role for a couple of years. And that actually had a bad effect on me, because my knowledge about all that the Java ecosystem actually stagnated. So I didn't learn many new things about Java because I was focusing on the business logic, which was great for the project because I got used to it and I got a better understanding for that. But I did stop to look left and right of that. That was bad for me. So my advice to you would be to try and rotate responsibilities within your project, if possible. And it seems like management would not want this because everybody has to, work slower in a way, because you have to find yourself again in that new position, in that new responsibility. But actually, there's a huge benefit for it. There are a couple of huge benefits for it. First of all, the buzz factor again. So if you rotate these responsibilities, you get less silo mentality in this project, because everybody knows every role in that project, and that's amazing. You get a lot of knowledge transfer again. And you learn new things. Every part, every person in that project will learn new things in a different role, in a different responsibility in that project. And if you can't do that, you can also ask for external help. So a lot of people are in a project where there's only one person, but you can hire some temporary external help for a couple of weeks, and they can look at your project and see if that's interesting, if you could maybe do something better, or if they have good tips, something like that. And most of all, it breaks down barriers. So it makes all these people happy to just do other work from time to time, usually, at least. You might say, well, Johannes, this is all well and good, but in our project, and yes, I know every project is different, and everybody has their reasons why they can't do this or that. But there's always a but. Too many changes raise rejection, right? If you put all these changes from today until tomorrow, then people might not like that. So what you want to do is take baby steps, little steps towards the goal, to all the things that I just said, and not making a step back in this case a lot of times is a step forward, which is great. So yeah, you want to make baby steps. You want to try to get every member of the team on board. You want to make sure Robert and Juanita, Bob, Johannes, and even Salvatore are on board with your new ideas, because otherwise you will have big problems. You won't come to that place where you want to go. And steady growth is nothing bad, right? It's growth nonetheless, even though maybe it's slow or something, but growing, slowly reaching your goal is still reaching your goal eventually, and that's what you want. My tiny tool of choice, of course, are the XDev commit cards. I'm sure a lot of you already saw them, or maybe even have them already. They are 32 basic ideas on how to improve your code. We are giving them away for free at the booth. You can come by anytime to get them. Yeah, this is our booth where Jonas and Arne are smiling at you. I will be there as well. I also am available for these one-on-one meetings. I don't know how they work yet, but I will. And I'm also have these mentor meetings about from solo dev to teamwork, which was also a basic idea I just told you. But that was basically it. There's this QR code for my presentation. There's the QR code for the Slido. And now I will try to open Slido, if there are any questions. All right, so one person said this was intermediate level. It's clearly beginner's level. That's true. I don't know where that went wrong. I'm sorry about that. Okay, now we have only 3 questions, which is strange. All right, suggestion, split the step, do the work, the fun part, by dividing it up into create a failing test case, the tricky part, and fix it, the satisfying part. All right, I will meditate on that. Any tips on motivating developers using Git the way it's meant to be used? Oh, that's a great question. Yeah, what happens, what helps us a lot is simply do it yourself first, and then try to find arguments and let the developers that are not motivated for some reason see that it works, how it works. So a lot of times you can tell these people to just try it out for a week or something like that, and then they usually see the benefits, hopefully. But I mean, a lot of people are just, they don't want to do that change. It's not that uncommon, unfortunately. Does life expectancy 56 refer to life experience or life expectancy or expiration? That's fun. No, it's I thought I said it enough. It's life expectancy. So, but that was, of course, just a fun thing. Okay, the questions are disappearing, but I think I got all of them. If you have more questions, we have still 3 minutes left. That's amazing. So you can just raise your hand now or come to me later. Yeah.
Can you tell please a little bit more about rotating responsibilities?
All right. Okay, so what I mean by that is you have a team, you have how do you say that, like a team leader, right? And you have some programmers, and a lot of times these programmers have specific areas where they are working on, where they are experts, basically. And what I recommend is that you change these responsibilities. So an expert in some certain area might get into a different area, just so he sees some other things, and you might even change the team leader sometimes. So a developer becomes a team leader. Of course, that's more difficult, and you can't do that out of the blue. You have to onboard them and stuff like that. But it's really good for people to put themselves in different shoes, in different responsibilities. So they learn a lot of different stuff and see how the other person feels and what he does, or she does. Right?
Many of the developers have different technical skills. It seems to me difficult to change responsibilities.
Yeah, that's not always possible. I'm sure if you have completely different experiences and a completely different background, it's not always possible. Sometimes it's even possible, but it takes some time, right? So to learn a complete different language, that's difficult. I understand that. But if you want to do that, you can actually tell the other people to learn a different language first, like a part-time or something like that, and then switch the responsibilities. That's something you could do in this case. Yeah.
Maybe in addition to this, we can try pair programming.
Oh yeah, that's a great thing as well.
Reduce the bus factor to
Yeah.
experience.
Yes, that's basically the more hardcore option than having peer reviews and pull requests, pair programming. Yeah, it has many advantages. Yes?
How can we develop the motivation for documentation?
I'm sorry, what?
I mean, how can we motivate to document stuff?
Oh, okay, yeah.
From legacy, senior people. Like, how can we motivate them to document?
Yes, that's a good point. And issues are one part of that process for me. So if you have issues, you're already documenting, right? You document the problem, you document some bugs, like that, and then you have to write something in the issue, and you can tell the people, the developers, to put more stuff into the issues from time to time, and then motivating them is just really difficult. That's a good question. But it should be self-evident that it's a good thing to document. Because if they have a problem and they fix it and they come back to that a few weeks later or something like that, it's a problem for them as well, I'm sure. Because they don't remember what they did. They don't remember why they did that. So they should document solely for the sake of themselves, but also for the other people as well. Yeah, but that's a good question. Suggestion, use lottery factor instead of bus factor. All right, that could be another word for that. I like the fatality of the bus factor. It really gives it some power, so everybody knows about that. Yeah. All right. So I think the time slot is gone anyway. So thank you very much for listening, and maybe we see each other at booths. Yep.